Now this is recording. RTI
International
Center for
Forensic
Science
presents
Just Science.
Welcome to Just Science, a podcast for forensic science professionals and anyone who is interested in learning more about how real crime laboratories work. In this episode, Just Science recorded a phone interview with Dr. Rob Maher from Montana State University about his NIJ-funded research in crime scene gunshot acoustics. Crime scene investigators are dealing with more audio forensic evidence as cameras are becoming a prominent fixture for law enforcement and personal cameras are easily accessible for most citizens. Being able to interpret and identify the many variables associated with audio forensics is very important. For example, the acoustic characteristics of a firearm versus the acoustic characteristics of different environments involve many variables. Dr. Maher takes us into the world of audio engineering and forensic science with this week's episode of Just Science. Funding for this episode is brought to you by the National Institute of Justice's Forensic Technology Center of Excellence. Here's your host, Dr. John Morgan.
Welcome to this episode of Just Science. This week, recording podcasts with a variety of folks who participated in the NIJ Research and Development Symposium. There was a very nice array of folks who gave updates on their research or reports on implications of their research. I really recommend that you go to our Just Science webpage for this podcast and learn more about Rob Maher's research. So, Rob, you're in Montana. You're based in Montana, right? So tell me a little bit about what kind of science, more broadly than just the audio forensics work that you've been involved in.
Yes, thanks, John. I'm a professor of electrical and computer engineering, so I teach all of the subjects in the EE field, circuits, electronics, instrumentation, communications, and so forth. And I'm also the department head here, which means I'm in charge of some of the day-to-day operations of the department. My background has been largely in audio engineering. I'm a music lover and have been able to find ways in electrical engineering to apply the work I do in entertainment audio. But for about the last 10 years or so, I've become interested in audio forensics and have had various projects and involvement in the forensics field.
So that's very interesting. I have to tell you that I've been paying attention to gunshot detection for a number of years, and there has been an awful lot of work, but entirely within the industry, about understanding I don't know whether I would call it audio forensics, but certainly understanding the relationship between what you might hear in audio stream and whether there's been a gunshot or not. How much of that actually is published out there in the open literature? How much of that were you able to lean on as you started into the work that you're doing, which is in audio forensics per se?
So the audio forensics field covers several different areas. Authenticity is one of the important areas. Enhancement is another aspect of audio forensics, trying to improve intelligibility or pick up background sounds in a recording. And then the third area is this interpretation and documentation area, and that's where typically the gunshot acoustics work comes in. And within gunshot acoustics, there are sort of two different sides to this. One is what you've mentioned, which would be gunshot detection, and this would be a real-time system that would try to determine on the fly whether a particular sound was a gunshot, and then perhaps where that gunshot took place and maybe the orientation of the firearm or classifying the firearm perhaps. And then the other part of gunshot acoustics is more of the forensic reconstruction work, and that's primarily where my work has been focused. So this would be recordings from a 911 call center or a surveillance system or perhaps an officer's vest camera that would have audio evidence that might include gunshots, and then trying to interpret the timeline, the shooter location, deal with questions about perhaps witnesses who had conflicting testimony and trying to resolve those sorts of things. But your question about is this published, I think 10 years or so ago when I got interested, I received a call from an attorney who had a tape and was asking if it was possible to determine if there was a gunshot on this tape, and then more specifically, was it possible to pin down to like the serial number of the gun from its sound. And my first reaction was, well, I don't think that's possible. And after I hung up the phone, I started thinking, gee, I don't really know. So I started doing some research and trying to look around what was out there, and really found virtually nothing published in a normal scholarly manner that was useful. And then that got me thinking for my own research that I should get into this area and do a little bit more objective measurement.
Yes, I mean, it really is a very rich area for our work, I think, especially given the fact that we're in a society where we're recording all sorts of audio and video, and being able to exploit those forensically is becoming more and more important as the years go by. I'm thinking of two cases that come to mind where this was at least been raised. The one is the Grassy Knoll, right? Was there another gunshot heard in the, that didn't belong to Lee Harvey Oswald? So that's, been part of a million conspiracy theories. I don't know whether you've actually tried to look at that or whether you know people who have.
Well, over the years I've been involved in this, I probably get a call once or twice per year from somebody who has a particular opinion about interpreting evidence from the John F. Kennedy assassination. There are a lot of questions about the authenticity of the various purported recordings, and so, I've not spent much time myself trying to deal with all of that, but it's certainly a sensational example of audio forensics work.
Yeah. The other case is probably a little bit more down to earth that comes to mind, and I'm reminded of a case that happened in D.C. that was quite noted there. They have a fairly extensive gunshot detection system in D.C. They have a lot of recording that's done of it. They picked up a particular gunshot, or a series of gunshots actually, as I recall. One evening there was a victim that was found that was associated with the area around those gunshots. And what came out was the theory, based on the audio forensics, was that the gun used was a particular model associated with the Metropolitan Police Department. And there was a particular officer who was off duty at the time who was implicated in the shooting as a result of the analysis of the audio forensics, which is fascinating. But I was not aware until I saw your work that there had been a lot of research associated with particular noise with a particular even class of firearm.
Yeah, and I want to make clear had not been involved in that particular case in any way. The example that you've given, though, is one of the things that often comes up in a forensic investigation, where there may be some physical evidence available, there may be some witness accounts, there may be some other aspects of the investigation, and then if there's audio evidence available, sometimes that can provide a different angle or a different viewpoint, so to speak, of the situation and what happened. One of the things that I've wanted to point out in the research that I've published in Gunshot Acoustics is that gunshot sounds are very unusual and very peculiar. We all know that they're a very loud sound, the muzzle blast of the gun, but it's so loud that very often the recording systems that might pick up that sound are really not designed to handle the really high intensity sound of a gunshot. So the recording system often is clipped, meaning it distorts the sound by not being able to capture the really, really high peak. And the other aspect of the gunshots I think is really important for people to know is the muzzle blast itself is extremely short in duration. It's maybe 2 or 3 milliseconds long, 2 or 3 thousandths of a second. So the bang of the gun is really just a pop. I've seen witness testimony several times where witnesses don't think they heard gunshots. They said, well, I thought it sounded like firecrackers or something else, because they were assuming that the gunshot would sound like what we hear in Hollywood movies and video games, which is this huge booming, kind of sound. So the difficulty is that most of the sound that people hear with gunshots isn't just the sound of the gun, but it's that sound reflecting off the ground, reflecting off buildings, cars, other obstacles. In many cases in these gunshot detection systems, a microphone that's picking up the sound isn't even a direct line of sight with where the shooting took place, and so the microphone's picking up the sound that's been bouncing around off these objects in the environment, and therefore it is not a particularly good rendition of the original sound of the gun, because it depends on all of these other factors. So it makes the analysis of these recordings quite difficult if what you're trying to do is classify a particular firearm. The nice thing is that sometimes the reflections and the reverberation of the scene actually provides useful information. because if there are distinct reflections or echoes, that can be correlated with a particular shooting location or a particular orientation of the gun, and then that can be used in the analysis to try to pin down where that particular shot might have come from or which firearm might have made that shot.
Right. I don't want to get too far ahead of myself here because I haven't really stepped through this so I understand it well, but what you're saying is that the echoes do have information. They are interesting from the perspective that they might help you get into the dynamic range of interest, and the feature set that you see within the echoes is not completely unrelated, in terms of your ability to mathematically relate them from the original clean, as it were, sound of the gunshot. Is that right?
Yes, it is correct, and it also points out that there are these other details that have to be considered. For instance, one of the techniques that's sometimes attempted with gunshots is to use a correlation between a recorded gunshot and a representative sound of that particular firearm to try to see the degree to which the two waveforms match. And my research is pointing out great caution there because often the recordings are including these ground reflections or reflections from other surfaces that can cause difficulty doing those simple time domain matching techniques. The other thing that our research has pointed out is that gunshots are not just a point source of sound, but they're highly directional. So the sound level out in front of the firearm, the direction the gun is pointing, is substantially louder than the sound off to the sides and behind the shooter. And so taking into account that directionality of the gun is also important and in some cases can be useful in an investigation as far as a question about who shot first or in the case of a standoff, or if there were multiple firearms discharged in the particular incident.
Yeah, I had never thought about the directionality issue. I mean, it makes sense that it's much louder in the direction of the shot. So let's take a step back a little bit and revisit what you were saying about the audio systems themselves. So I assume that most audio systems are going to have a dynamic range, basically 128-bit dynamic range, and then their sampling, it'll be in the tens of kilohertz or something of that nature. I mean, how do most audio systems that you're actually going to be pulling real evidence off a sample? What are the limits of it usually?
Yeah, so most of the typical audio recorders, a memo recorder that an officer might be carrying, or a vest camera, or the camera in a taser device, or a dashboard camera in a police cruiser, are typically set up to record speech and utterances of people. And so sampling rate for these systems is typically maybe 8 kilohertz or 12 kilohertz, so that's 8,000 or perhaps 12,000 samples per second. In a system like that, then the signal processing says that the bandwidth of the actual audio information is up to about half of the sampling rate. So that would mean a bandwidth of maybe up to 4 kilohertz or a little higher for these speech devices. So any of the sound energy that's at a higher frequency, ultrasonic even, won't be recorded by those types of systems. When we're talking about a extremely abrupt sound like a gunshot, the details of that waveform are going to be difficult to pick out when the sampling rate is relatively low. There are situations where even with a speech recorder there can be some useful gunshot information obtained if it isn't too close to the shooting location.
So let's talk specifically about your research at this point. So how did you then approach the sampling problem? Obviously you can sample with much greater fidelity than what those systems are going to sample. So how did you approach this problem of trying to understand the acoustic signatures?
So for the research that's being sponsored by the National Institute of Justice, what we were proposing to do and what we've done now is to make essentially laboratory-style recordings. So we set up a very repeatable and consistent and controlled experiment in which we are firing different guns from a known location with microphones that are designed to record these very high amplitude sounds, and we are elevating the shooting position and the microphones off the ground by about 3 meters so that the recording picks up the direct sound of the muzzle blast of the gun in its entirety before any reflections start arriving off the ground in other places. So what we're trying to do is sort of the best case you can imagine to try to record a gunshot with the idea being that this will give us a baseline or an understanding of what information could be available in the very best case. But then clearly in most of the forensic investigations, the quality of those recordings will not be as good as these research recordings, and so part of the future research is to try to correlate these subtle details of the laboratory recording to what we get from what is available from an actual forensic investigation. And I hope also that down the line what this might do is encourage some of the manufacturers who are making these recording devices to consider some ways in which they might include a channel or include other information that would be more useful specifically for these high amplitude sounds like gunshots that would aid in investigation if the device picked up that sort of a sound.
Well, yeah, and I have to admit this is not an issue I had considered before in this context, because there's been a great deal of work looking at the quality of the video that things like dash cams and so on produce, right down to the point of if the dash cam is X meters away from a license plate, how many pixels do you need to make sure you picked up the license plate reliably?
Right. Yeah, exactly.
Yeah, but there has never been an equivalent consideration on the audio side that I was aware of.
It's a complicated thing because nowadays, again, many of the audio recording systems not only have these limitations of the microphone and the sampling rate, but following the actual acquisition of the signal, typically these systems are using an audio perceptual compression algorithm. I think people are generally familiar with MP3 files or things like that. Or when you're talking on a mobile phone, the voice, the speech that you're putting into the phone is actually then encoded for efficient transmission, and it's trying to retain the parts of the signal that allow you to understand speech. So when you present a peculiar signal like a gunshot to a speech coder, that gunshot signature doesn't look in any way like normal speech signals, and so it's not clear how that digital coding algorithm is going to represent that signal. And so that's also a challenge, especially with cell phones and with vest cameras, is understanding the effects of that audio coding representation of the waveform. And again, I think this is something that's not really fully understood or fully studied, and that'll be, again, another area for some interesting research.
Well, one of the themes from all of the podcasts thus far that we've done from the American Academy of Forensic Science meeting is this idea that if you're going to do science, you've got to start at an idealized case, because you simply cannot start from a place where you're looking at recordings that aren't giving you very good information. You need to be able to start from being able to see what the best information is, so that then you can start understanding what those compromises might have in terms of impact on the sound that you're able to detect. I certainly appreciate where you're coming from.
It's really a challenge because if you're presented with a recording that has various noise and distortion in it and then try to draw conclusions from that, that's, of course, a very important thing to do in a criminal case and needs to be done. But ultimately the question of how good can you do, what types of information might be available does go back to this more scientific view of starting with the best case and saying, well, what is even theoretically possible, and then understanding that in a real case probably everything will not reach that ultimate standard that you might get in a perfect situation. But at least it sets a bound on what to expect.
Now, you are getting some interesting data from that perspective in the sense that you at least have ground reverberation potentially to take a look at. Now, have you taken a look at those kinds of effects in this research study per se, this particular one?
This particular study that we've been doing has been more looking at the differences between different firearms. And so we tested 10 different types of guns, several rifles, several different types of pistols, and a couple revolvers. And we are making recordings with 12 microphones at one time, and these are placed in a range of azimuths and a range of directions around the gun, from out in front to off to the side and then ending up around behind the shooter. So we're getting a picture, if you will, of what the sound of these different guns does as a function of direction, and then we're comparing one firearm to another to try to see if there are distinctive features that might be useful for categorizing the characteristics of that particular gun.
Tear apart for me a little bit, if you can, what is causing the audio? I mean, when I think about it, looking fairly closely at the pattern evidence signatures, and of course it's very tightly correlated with what striations you have on a bullet or firing pin impression. those are very particularly well understood, obviously, with respect to the mechanical action of a firearm. Are you looking at it from that perspective, or are you just looking at it just plain phenomenologically? You know, this is the mathematical picture of it. I mean, how are you approaching that part of the problem?
Yeah, so far we've been looking more at the empirical information. So we're making a recording of a particular gun, and we're recording the model of the firearm and the type of ammunition used and so forth. And so we're simply collecting this information and going back then and trying to correlate any aspects of the acoustics to, let's say, the caliber of the gun, or the length of the barrel, or the amount of propellant in the cartridge and things like that. We've not done that yet, but that would certainly be an interesting parameterization to do and try to see which of these parameters have an effect on the sound itself. Basically, the interesting types of features that I can give a couple examples is if we compare the sound of a firearm that's shooting a bullet that is supersonic. The bullet leaves the barrel traveling faster than the speed of sound. The sound of the muzzle blast, the gas escaping behind the bullet from the barrel, but the bullet itself, if it's traveling faster than the speed of sound, it also makes a sound. It creates a mini sonic boom as it travels downrange, and that shock wave due to the supersonic bullet can also be detected if the microphones are in a downrange position. So it's possible in some cases that the sound of that bullet gets picked up by the microphones as well as the muzzle blast, the bang of the gun. Another interesting characteristic for handguns is that a revolver, this is a firearm that has a cylinder with multiple cartridges loaded in, and then the cylinder is rotated to align the firing chambers with the barrel. The sound from a revolver comes out of the muzzle of the gun just like any other pistol, but there's also sound that is emanating from the gap between the cylinder and the barrel of the gun. And so as the propellant is combusted, sound emerges from that gap first. The bullet is accelerated down the barrel, and then sound comes out of the muzzle, and the slight timing difference between those two sounds can actually be picked up if the orientation of the microphone is off to the side of the firearm. So these are the sorts of details that potentially in a recording might distinguish between these different types of firearms if there wasn't other information available.
Right. So that gets to the start of the question you had at the beginning there. Could you map this to a particular serial number? Well, the first step to that is, can you match it to type of firearm? And what you're saying is, at least to a first order, you should be able to, once you have the data, to distinguish between, say, revolvers and semi-automatic pistols.
Right. So there's some features there that at least, based on empirical analysis of the data that we've been seeing, could potentially be used to distinguish those two types of guns.
Right. And you've actually looked at those two types. You've looked at rifles and shotguns as well. So part of what the issue here, too, is that, again, the analogy with ballistic impression evidence is that, their contention, the core of their field, is that the patterns are persistent across firing. Now, I assume you looked also at the persistence of the signatures as you fire the particular weapon multiple times. Is there anything you can comment on with respect to whether these signatures are persistent for a particular type of firearm?
Yeah, the consistency is one of the things that we were interested in finding out about. For the experiments that we've done so far, we didn't carefully match the ammunition. So these were cartridges taken out of a commercial box. So the manufacturer presumably has whatever standards to try to equalize the amount of gunpowder in the assembly and so forth. But we didn't do anything extra to try to match that. So in the experiment, each of the firearms was shot 10 times in succession. So the marksman got into position and then fired the gun 10 different times, one after the other. And we've looked a little bit at the consistency from one shot to the next. By and large, there's not any drastic differences we're noticing, but there are occasionally where one of the shots will have a slightly different acoustical character than another. And the reason that we're interested in that is ultimately if you were trying to do the kind of classification that often comes up in an investigation, ruling in or ruling out a particular firearm, you'd like to be confident that there wasn't large variation from one shot to the next. Now, in the cases what we did here, of course, these guns between the first shot and the 10th shot, I'm not a firearms mechanical expert, but I'm imagining the gun is getting hot. The residue from the first shot and the second shot and so forth is accumulated. So there could be some physical differences in the gun that would have to be correlated to any change in the sound. But so far we've not had that level of investigation.
So the next question then becomes, is there reason to believe from the data? And again, we're thinking about this from an idealized case in the sense that this is excellent data comparatively with what you would probably see in practice. In the idealized cases, does the data suggest that it's possible to do type classification of firearms based on acoustic signature?
So if we did a test in which one of the 10 that we've tested was brought out and fired, and we knew the orientation of the gun and we knew where the microphones were and so forth, I think it would be possible manually to then recognize what gun made that sound. But if we did what's probably more realistic, which is you just choose a random shooting direction and a random distance and a random orientation and so forth and made the shot, then I think that question is much harder to answer. The variation with angle, with azimuth for one gun may be greater than the variation between two guns at the same azimuth. So these sorts of questions, again, I think are the things that ultimately need to come out of this research.
To some extent, I guess it would help to know the geometry around the firearm in question, but you also might be able to derive some of that geometry from at least to first order, from the structure of the reverberation overall, and then maybe determine something with respect to the orientation of the firearm itself within the echo signature itself. Is that about right? I mean,
The actual forensic cases I've been involved in, often there is some physical evidence or some undisputed witness comments or other types of things that are available. So for instance, if the audio is coming from a dashboard camera in a police cruiser and the video is available and it is clear where that car is parked with respect to landmarks visible in the scene, and increasingly at a scene of an incident there's often several cars all recording separately, and sometimes the officers have wireless microphones that are recording also, and so if a gunshot occurs there actually may be half a dozen recordings of the sound from different vantage points. Then that's where those comparison between the different recordings and the relative timing and the echoes and reverberation become pretty useful in trying to pin down the who shot first question, or which position did that first shot come from, those kinds of things.
That's an interesting question of then, if you have the actual case, it's limited dynamic range and it's limited in sampling. But on the other hand, you also have potentially a lot more data than that might suggest. You might have multiple recording devices. You might have several different echoes from which to derive information. To what extent have you been able to do analysis, I know it's relatively early, that allows you to relate one to the other?
So I don't think I can say that there's a sort of a standard way that works in all cases, but a couple of the cases that I've been a consultant on, looking at the evidence that have been available, one involved a shooting. There were two individuals who fired guns. There's no video of the altercation, but a nearby residence had a surveillance system that had multiple cameras and microphones that picked up the sounds associated with this incident. And based on those recordings, it was possible to pick up a very distinctive echo difference between the first two shots in the sequence that would then lead to the conclusion of a particular gun, the orientation of that gun being the one that fired the first shot. So that sort of thing is possible. Another case I was involved in that had multiple law enforcement vehicles parked nearby, the question was whether a taser deployment occurred before or after one of the officers fired a service gun. And the question then from the audio was whether it was possible to hear the deployment of the taser darts separately from the sound of the gun, and what is the relative timing there. So these are the sorts of things that would be involved in this type of audio investigation, especially in cases where there isn't any video evidence to show the scene of what happened.
So one of the points you made the other day in your research presentation is the need to characterize the audio recording equipment itself And I assume that that would apply also with respect to video recording equipment, because we're collecting enormous amounts of this data. It's being used in casework. It isn't necessarily going through crime laboratory, but it's still forensic evidence and has not necessarily been subject to the same kind of scrutiny and or quality assurance processes that traditional forensic evidence is subjected to. To what extent do we really even know how to look at audio recording equipment and its fidelity with respect to these kinds of problem sets?
Well, it's a very good question, and I don't know in any given jurisdiction how the court will interpret the chain of custody of these types of systems. I think in some of these cases this information is being collected from the law enforcement officers' vest cameras on some basis and I guess logged into a system and time tagged, and I know in some cases I've heard that they are deleting these files after some period of time just because they accumulate more and more. So all of those types of handling things is a good question, and I don't know if there's a scientific aspect to this, but it's certainly a policy aspect that the justice system's going to have to contend with.
So where are you in your research right now? Do you still have time left on your grant? You're still working on it, or is that completed at this point?
The grant itself was concluded at the end of December 2016, so the grant period is now over, but the information that we've obtained, I'm in the process of writing a variety of papers and reports using this information to derive additional findings, and there'll be several audio forensic conferences in the coming year that this information I'll be sharing.
Is there a particular website that you used as a way of trying to get that information out to the community that we can point people to?
Well, my university website here at Montana State University is where I'll be posting this information, and I'm just waiting right now on the archive people at the university to help me get things put in a permanent web location. But if people search for my name at Montana State University, they'll get my personal website, and it has links to the papers and other information about this project.
I have to admit to a certain frustration. I think what you're doing is the start of what is a very rich area of work. And I want to see you do a lot more of it. I want to see you building around it. And so I hope that there's things that we can do to help spread the word a little bit about not only the work that you've just done, but also the needs that exist out there in audio forensics.
Yeah, I think, as I mentioned when I first got involved in this, it was clear that there was a lot of proprietary work that had gone on, various commercial providers in gunshot detection systems, and then there was some, secret work going on the military side for sniper detection and localization systems, and the lack of having any sort of more open public information that different researchers could look at and understand was frustrating. So I've been interested to try to provide that information and get it out there. So that's certainly something I'm committed to do. And the other thing is that having observed a small amount, I don't do this full time, but in the consulting that I do, there's often cases in which some of the testimony relating to gunshots that is being used by individuals in court testimony, I just don't think is good. It's not based on science, and so I think having a little bit more education about what's sensible and what's scientific can be of great advantage to the court system too.
I am a little bit familiar with some of the work on the secret side of things. I think that if there are deficiencies in some of the testimony work, you can probably multiply that by some factor on the secret side of things. So you're doing excellent work. I'm glad we were able to highlight it to some degree here today. And
I will say, John, I think that it's does credit to the National Institute of Justice that there's support for this kind of work going on, because I think it is important, and for individuals who are put in jeopardy in a criminal case, having the quality of the evidence and the testimony and the interpretation as good as possible is really important. So very pleased that NIJ is supporting this kind of work.
Yeah, we definitely love NIJ at the Forensic Technology Center of Excellence. And you're right. I think the approach that NIJ takes, which is really trying to establish that foundational science across the board, not only forensic science but in other areas, is so critical and obviously needed. Thank you so much. Another fascinating discussion here on Just Science. Appreciate your time.
Well, it's a privilege to speak with you, and thanks again for the interest.
Opinions or points of views expressed in this podcast represent a consensus of the authors and do not necessarily represent the official position or policies of its funding. Next week on Just Science, we will be taking a short break before an exciting season of case studies. Each of these stories have a unique or unusual means to catching perpetrators. We will hear from those who were part of these cases, including the perspective of an attorney, investigators, forensic professionals, and crime lab directors. Please visit the FTCOE's website at forensiccoe.org to learn more about this episode and to watch the 2017 NIJ R&D Symposium webinars that were highlighted in this special release season.